Welcome back. This is Financial Analysis Using Excel, brought to you by the CCIM Institute and the Ward Center, and I'm Jeff Engelstad. This is Session 7. In Session 7, we're going to take a very good look at the modified internal rate of return as it relates and opposes to the internal rate of return. We're also going to look at the concept of net present value in terms of the concept of gross present value or investment value. And so we're going to be looking at the reinvestment rate assumption within the internal rate of return or lack thereof. And we're going to be looking at reinvestment and safe rates or finance rates and things like that. And so some of this is a really good high-level review of concepts of net present value, internal rate of return, and modified internal rate of return. And we're going to use some spreadsheet techniques as we go along as well. Okay, so we're going to look at internal rate of return and some other financial measures using Excel. You can also use this as a test of your knowledge of finance in general. Take a look at the A series of cash flows. You have a $100,000 initial investment, and then you return $15,000 every year, and at the end of the holding period, you get back your $100,000. If you understand fully the concept of internal rate of return, you know what the internal rate of return on this investment is before you calculate. And that internal rate of return will be 15%. Because look, you get a 15% dividend, a 15% dividend, a 15% dividend, a 15% dividend, and then your final 15% dividend, and then you get your money back. So you know what you received? You received 15% on your internal investment of $100,000, and your investment balance never moved throughout the holding period. So let's use Excel to calculate this, and as we've done before, we'll just bring up the internal rate of return function. And if we don't see it right away, you can just type in IRR, and there it is. And it wants the values and the guess. Well, we put in the values 0, 1, 2, 3, 4, and 5. And then, of course, we've talked about the guess because it's an iterative function that provides for a guess, and because there are possibilities of having multiple results, and so it provides for a guess. I typically don't guess for Excel. So put it in. There it is, 15%. Even if we bump it out a couple decimal places, it's exactly 15%. Now, armed with the knowledge that this investment has a 15% internal rate of return, and your discount rate is 12%, what is the value of these cash flows? We know what the cost of these cash flows is. The cost of these cash flows is $100,000. However, that cost may or may not equal the value of those cash flows. So gross present value would tell us the value of receiving these cash flows. And when would it tell you the value? Today, at time period 0. And if we're discounting these cash flows at 12%, yet they yield 15%, then the value of the cash flows will exceed their $100,000 cost. To calculate the gross present value or the investment value of a series of cash flows, we use the net present value function in Excel. So let's type in NPV for net present value, and we'll grab that function. You may remember we talked about this a little bit before. This net present value function in Excel, within its function arguments, will not solve for net present value. Within its function arguments, it will solve for gross present value or investment value. So we apply a rate, and then we take those values that are subject to being discounted at that rate. So that would be cash flow 1, 2, 3, 4, and 5. We're not going to discount cash flow 0 because where would we discount it to? It's already in the 0 position. So you can see that within the function arguments, we have a result that is $110,814.33. That is the value of these cash flows discounted at 12%. Therefore, we already know what the net present value is going to be. I could go right over here and say the net present value is going to equal the total value of the cash flows minus the cost of the cash flows. So it's the difference between value and cost, or $10,814.33. In order to solve for that in Excel, we bring up the net present value function again, and note what we're going to do. The same thing. Put in the discount rate, put in the values that are subject to that discount rate, and notice we've solved for the gross present value of $110,814. In order to make this truly net present value, we have to leave the function arguments and deduct cash flow zero. Now, cash flow zero is already negative, so we're going to add it. When we add cash flow zero, then we get the result, $10,814.33. Probably the most common mistake that people make in Excel relating to net present value is this. This will be done incorrectly. Take the net present value function, apply the discount rate, and then put in all the values, 0, 1, 2, 3, 4, and 5. And the reason that that makes some sense is because that's how you calculate an internal rate of return. And so it really makes sense that you might do it that way. However, look what you're going to get. You're going to get the wrong answer. The wrong answer is $9,655.65. Now, let's see if you're really paying attention. What is the relationship between the $9,655 and the $10,814? You know how we can get from $96.55 to $10,814? Or rather, get from the $10,814 to the $96.55? We could go either way. But you know what we're going to do? We're going to discount it. One period. So let's do this. Let's use present value. At 12% for one period, let's discount $10,814, which is the real net present value, and look what we get, $96.55.65. So you know where this thing lives is up here somewhere in time period -1. It doesn't make any sense. So don't be among those who solve net present value incorrectly in Excel, because, you know, here maybe that's not a big difference, but believe me, it can be a big difference. And net present value, if you understand it correctly, it's the difference between value and cost. Well, the net present value function in Excel is an absolute champion at solving for the value of cash flows. All you have to do is net out the cost, and you have net present value, a true net present value. All right, let's take a look at the same cash flows again. $100,000 investment, $15,000, and then a return of your $100,000 investment in 5 years. And we already know what the internal rate of return is. It's 15%, but it's just so easy to calculate in Excel that we'll do it again. We take the values, 0, 1, 2, 3, 4, 5, all of them, and it correctly solves for the internal rate of return of 15%. Now what we want to look at is the modified internal rate of return. What is the relationship between internal rate of return and modified internal rate of return? And those two things are related through what you're going to do with the intermediate cash flows. And since these intermediate cash flows are positive, we would be reinvesting those. And the modified internal rate of return allows us to put in an explicit reinvestment rate. If we reinvest all the cash flows that we get at 10%, then the modified internal rate of return will be less than the internal rate of return. The internal rate of return is measuring just this investment. In this case, just this $100,000 investment balance as it goes through time and remains $100,000, because internal rate of return is dividend plus growth. In this investment, we have no growth. We buy for 100, we sell for 100. The only thing we have is a level dividend of 15%. So the internal rate of return is 15%. The internal rate of return does not say what you could or would do with these cash flows. Now, of course, if you continue to reinvest those cash flows at the internal rate of return, nothing will change. And so that's mathematically provable, and that's why you'll find in some finance textbooks, and you'll find some very smart finance folks that say that there's an implicit reinvestment rate in the internal rate of return calculation that is the internal rate of return. I'm okay with it. I mean, you can prove it mathematically, but it doesn't work in the real world. Because this investment has a 15% internal rate of return, does that mean that all of the other small investments that I might make with the cash flows will also have a 15% internal rate of return? I don't believe that. So $100,000, I can get a 15% IRR. But what about for $15,000? I don't think I can. I think I can reinvest that at 10%. So what modified internal rate of return is relative to internal rate of return is a portfolio approach. And in fact, modified internal rate of return, MIRR, is probably the most common name for the technique, but it's not the only name. You will hear this called adjusted IRR. You'll hear it called portfolio IRR. I think portfolio IRR is the most descriptive because it is the internal rate of return of this investment and all the little investments that are spawned by it, right? So let's bring up the function modified internal rate of return, MIRR. Click OK. It wants the values, just like internal rate of return. Notice it doesn't ask for a guess because it's not going to iterate. We go back a few sessions when we did that proof of internal rate of return. You see where we looked at that in some detail. Well, a finance rate is used for negative cash flows. We don't have any negative cash flows, so we can ignore that. A reinvestment rate is what we're going to reinvest our positive cash flows at. And so while the internal rate of return on this investment is 15%, when we get cash out, if we can only reinvest that at 10%, then our portfolio IRR, or a modified internal rate of return, is 13.89%. All right. Now, gross present value and net present value we've already done with these same numbers in the previous example, but let's go ahead and do them again just to reinforce. For gross present value or investment value, this is answering the question, how much are all these forward cash flows worth today, right? So we'll bring up the net present value function, apply the discount rate, and then relate that to the cash flows that are subject to that discount rate. Cash flow 0 is not subject to a discount rate, because where would it be discounted to, right? And so there's our $110,814 net present value. We would do the same thing using the net present value function. We would solve for the gross present value, and then we would go outside of the function arguments into the formula bar and net out cash flow 0, and we would have our correct net present value result. Okay. All right, so now let's take a look at C. We've got a $100,000 investment. We have a $10,000 cash flow, then a $15,000 cash flow, and then we lose $10,000. Maybe we have a tenant rolling over that we're projecting in year 3. So we're projecting a loss in year 3. A big cash flow in year 4, and then we exit the property at the end of year 5. I can't look at this and tell you what the internal rate of return is. And I need Excel. I need to calculate this one. I know, however, that the internal rate of return is positive and measurable. And I'll tell you how I know that. I put 100 in. Actually, I have $110,000 going in, and I've got more than $110,000 going out. So again, remember, I say internal rate of return measures profit. Is the investment profitable? Yes, this investment is profitable. I can tell you that the answer to is this a profitable investment is a yes or no. It's not a I don't know, because it may not be profitable enough for you. I'm not asking you, is this investment profitable enough for you? I'm asking you, is this investment profitable? If I put in $100,000 and 20 years later I get back $101,000, is that a profitable investment? Yes, it is. It's a profitable investment. Is that profitable enough for me? I don't think so. So let's calculate the internal rate of return on this set of cash flows. We put in the values. And we have an internal rate of return. It says 15%, but I don't think it's quite 15%. It's a little shy of 15%, 14.78%. Now let's calculate the modified internal rate of return. We have a negative cash flow, and so we've got a finance rate or a safe rate that we're going to use together with the reinvestment rate in the modified internal rate of return formula. So let's bring up the function for MIRR. It asks for the values, just like internal rate of return. And then the finance rate, Excel's language here about it's a finance rate, and it says it's the interest rate you pay on money used in the cash flows. I don't know if that's really all that helpful. I like the term safe rate. If I know I'm going to lose $10,000, I need to set some money aside at a very safe rate. Now, today, 2014, what is a safe rate? I don't know, maybe 2%, maybe less than 2%. Some sort of a 10-year treasury rate or something like that. Finance is no fun without interest, right? So, let's just say that our safe rate is 6%, our reinvestment rate is 10%. Now we've got a modified internal rate of return that calculates out very precisely to be 13.55%. Now, alright, so maybe you understand modified internal rate of return, adjusted IRR, portfolio IRR, whatever you might want to call it. By the way, if you're ancient, you might have studied something called financial management rate of return, FMRR. I don't know if anybody remembers that or not, but I certainly remember studying FMRR. And financial management rate of return was some sort of a modified internal rate of return that had a few more rules involved with it. What's interesting about financial management rate of return is that it was developed by two professors out of the University of Connecticut, Professor Messner and Professor Finley. So Finley and Messner. All academics want to name something after themselves, and what better to name after yourself than a rate of return? And so they were trying to promote that as the Finley-Messner rate of return. But it didn't really work all that well, and so they settled on financial management rate of return, FMRR. But the punchline is this. Professor Finley and Professor Messner each weighed about 400 pounds apiece, and so their students affectionately called it the Fat Man's rate of return. Anyway, that's absolutely nothing to do with what we're talking about. But let's take a look at what the modified internal rate of return function in Excel does. I'm not saying it does it the perfect way, and I'm not saying that the modified internal rate of return the way Excel does it is the way everyone does it. But I am saying if you're going to use this, you should understand what it's doing. So if you've got a positive cash flow, you're going to reinvest it till the end of the term using the reinvestment rate. So this first $10,000 cash flow will be reinvested 1, 2, 3, 4 periods. And so it's a future value function. We grab future value, and we need our rate. So there's our reinvestment rate for 4 periods, no payments. We're going to, when we get this $10,000 cash flow, the reason I'm making it negative, we're going to turn around and reinvest it. And it'll grow to $14,641. When we get this $15,000 cash flow, it'll grow for 3 periods. So we'll grab future value and our 10% reinvestment rate for 3 periods. When we get that $15,000 cash flow, we will reinvest it, and it will grow to $19,000. This $10,000 loss that we're going to sustain in year 3, we need to save for. And so what the modified internal rate of return function is going to do is bring that back to time period 0 at the safe rate of 6%. So if we're going forward, we use future value. If we're going backward, we'll use present value. We're discounting it. So our rate is at safe rate of 6% for 3 periods in order to have the $10,000 to lose, we need to invest an additional $8,396 today. And then, of course, our $50,000 will grow one period, and it'll become $55,000. We kind of know that because it's 10%, but we can use the function and verify that. Future value, 10% rate, one period. We will invest the $50,000, and it'll grow to $55,000. Now, what have we done? Same thing as capital accumulation. We've taken care of all the intermediate cash flows. Everything is working for us. Remember, this is a portfolio approach. If we add up our $100,000 investment plus the $8,396 that we need to have so that we'll be able to lose the $10,000 in year 3, we've got $108,000 as cash flow 0. And then if we add up cash flow 5, we'll have the 14, the 19, the 55, and the 115,000, which is 204,000. Now, take a look at this. Modified internal rate of return calculated down to 13.55%. We can calculate the modified internal rate of return now by simply using the function rate. We've got 5 periods in this investment. We start with 108, and we end with 204. Guess what that is? 13.55%. This is the math that the modified internal rate of return calculation in Excel is doing. Now, think critically about this for a minute. If this were a real investment, I'm putting $100,000 in, I'm going to get cash flows for a couple of years, but then this tenant rollover is going to cause a negative cash flow in year 3. You know how I'm going to sustain this $10,000 loss in year 3? I'm not going to spend all the money from year 2. And so you could correctly take the $10,000 back one period and then net it against the 15. So the 15 would become a smaller amount. You'd have a smaller amount to compound forward, and you'd have a smaller initial investment, cash flow 0. But that's not the way the modified internal rate of return calculation in Excel is done. And because modified internal rate of return, MIRR, is a function in Excel, it's what's being used out there in the industry. I think it overstates your initial investment. Now, one of the things that you'll notice about a lot of financial functions and a lot of finance in general, in an academic sense, is it makes sense to err on the side of conservatism. This technique errs on the side of conservatism because this technique says, you really need $108,000 to make this investment. And I don't think that's true. I would be happy to make this investment with $100,000 and then save some money out of cash flow 2 to be able to sustain the loss in year 3. Would it change the modified internal rate of return? Yes. Would it change it by much? No. So this is slightly more conservative. It's an easier approach. If you remember doing the capital accumulation process in your CCIM curriculum, you remember we would do this. We would take the $10,000 back one period, net it against the $15,000, take the smaller amount, compound it forward, and if this $10,000 was $50,000, we'd have to net it against this and net it against this and then bring it back to 0. And so it was a real step-by-step approach. This modified internal rate of return, the way Excel does it, is a little more simple, which is nice. I think if you're going to use this technique, and people are using this technique, people still calculate internal rate of return, but they also calculate modified internal rate of return because the amount and timing of cash flows really does matter. I really am investing in a portfolio sense, even though internal rate of return doesn't have the ability to recognize that properly. Modified internal rate of return makes up for that. So you have that spreadsheet that we've just completed, and you have it as complete on the next tab, and you can go back through and practice that a couple times, and I hope that will all make very good sense for you. Thank you very, very much, and we will see you soon. Goodbye.